Hello everyone and welcome to another video. In this video we'll build a NodeJS program that will use machine learning to remove the background from photos. The approach I went for is use Tensorflow JS with a body-pix model to do person segmentation on the image and Jimp to remove the background. We'll also compare two versions of this model, RESTnet and MobileNet, to see which does better. Just wanted to let you know that the video moves at a pretty fast pace, so if at any point you need more time, you can pause the video or even adjust the video speed from the player's bottom right corner. So I say let's get started. First, we'll run npm init to create a new project. Next, we'll add all our dependencies using npm install. We'll use for this Node Jimp, TensorFlow models body-pix, TensorFlow TFJS, TensorFlow TFJS node, and Jimp. Now let's create an index.js file where we'll write our application. We'll start by importing all our dependencies: TFJS node, body-pix, fs, and Jimp. We'll write our code in a class called removeBackground so we can export and use it very easily later. We'll add a property called _model where we'll load our body-pix model. Now create a method called _loadModel. We'll check if the model was already loaded, and if not, we are going to load it. Also make sure to make the function async because we'll use await inside of it. Now let's declare another async method called makePrediction. This will have one parameter, the image for which we are going to make the prediction. Now we can just return the prediction using this._model.segment_person_parts, and we'll pass the image as a parameter. Also, don't forget to call the loadModel function that will check if the model is loaded, and if not, it will load it for us. And I'm also adding some comments. Now we can start defining our removeBackground function that will put together all our previous functions. Don't forget that this is also an async method, and it will also have the image as a parameter. Our image parameter will be a buffer, so we'll use Jimp.read to create a Jimp object out of this buffer. What we'll do here is load the image, make the body segmentation, and finally remove the background. To make the prediction, we first have to convert that image buffer into a tensor, so we'll do that using tf.node.decodeImage. After that, we can just call this.makePrediction and we'll pass the tensor that we just created. We store the body segmentation in a variable so we can use it later. Now it's time to make the magic and remove the background from the image. But first, let's move this Jimp image object after the prediction, because I think it makes more sense here. The body segmentation variable is an object that has the width and the height of the image, and also a property called data. So if we think to our image as being a matrix, we can iterate through every pixel of the image, and if it's not a body part, we'll just make it transparent. Now we'll also need a counter because the data is an array, it's not a matrix, so we'll need to keep track of the position inside the array. So let me give you a quick example so you can better understand this. If we have an image that's 5 by 5 and we want to access the pixel on row 2, column 1, we'll just use the position 5 in the array because it starts from 0. Now in the body segmentation data array, if we have -1, it means that's not a body part, and if the value is positive, that means it's a body part. So if that pixel is not part of a body, we'll just make it transparent. And we'll also increase our counter so we can move one position further in the array. We'll also add the second parameter to our remove background function, that will be the name of the output file. We'll use this to save our final image using jimpimage.writeAsync, and we'll pass our output file name as a parameter there. And that's basically it. Now we can use some images to test it and see if it's working. We'll read the image using fs.readFileSync, passing the path as a parameter. After that, we'll create an instance of our remove background class. Finally, we'll call our remove background method, passing the image and the output file name. We'll also move this into an async block, as we have an function that will return a promise. Now just add an image in the same folder so we can test it out. As you can see, the background was removed successfully. The image, it's not perfect, but take into consideration that we haven't made any improvements to the model. Let's now test with another image to see how it goes. And it's working, and I think the body-pix base model is doing pretty well, I think. So we'll now make a comparison between MobileNet v1 architecture, which is loaded by default, and ResNet 50. We'll add the ResNet config object that will define the architecture as ResNet 50, and two other parameters, output stride and quant bytes. What you need to know about this is that MobileNet is smaller and faster but less accurate, and ResNet is bigger, slower and more accurate. Now let's compare the output photos. As you can see, the images that were using ResNet 50 are a lot more accurate. That's it, so don't forget to like this video and subscribe if you haven't already.